Hello again and welcome to Crystal Clear Maths Solutions. So today we are going to solve this problem using first principles. So we are given a function f of x equals square root of x, and we are told to find the derivative of this function using first principles. So solution. So the first thing we need to ask ourselves is, what is first principles? So this is the method of finding the derivative of a function given by f prime of x is equal to limit as h tends to 0 of f of x plus h minus f of x or over h, where h is equal to small change in x. Okay, so we are given f of x to be equal to square root of x, which can be written as x power half. Okay, so what else do we need in order to have everything that we need in this formula? We need f of x plus h. This is going to be given by, so wherever there is x in our f of x, we will replace it with x plus h, and therefore f of x plus h is given by square root of x plus h, which is equivalent to x plus h power half. Okay, so what do we have? F prime of x is given now by limit as h tends to 0 of, what do we have here? F of x plus h is given by x plus h power half, then minus, what is f of x? F of x is x power half, all of this over h. Okay, that's what we have. Now remember, when you are applying limits, you are supposed to simplify the given function as much as you can. And for instance, if you replace h directly here in this function the way it is, you realize that in the denominator you will have 0, and therefore dividing the numerator by 0 will make our function undefined. Okay, so since we do not want such a situation, we will simplify this function further before we apply the limits. Okay, so we have x plus h power half minus x power half all over h. This can be given by, so because this involves square root, we can simplify it by rationalization, and this will be done by multiplying this by the conjugates. This will be given by x plus h power half minus x power half. Okay, so multiply this by its conjugate, which will be given by x plus h, okay, power half, then minus x power half. So since this is minus, this is going to be equal to plus. That is what is the conjugate of that. And then what we do in the numerator, we also do in the denominator. So we will have h into what we have here, x plus h power half plus x power half. So remember, when you have a plus b into a minus b, okay, this is given by a squared minus b squared. This is using what we call the difference of two squares. Okay, so this is what we are going to apply in solving this. This gives us x plus h power half, okay, by the difference of two squares. This is going to be squared minus we'll have x power half, then this is squared, this is all over, the numerator remains the same, so it will be equal to h into x plus h, okay, power half, then plus x power half. So that is what we have up to there. Now we simplify that further, and once we simplify that further, we will have, so we have x plus h power half squared is going to give us, x plus h, because this 2 will cancel with this 2, so we'll have x plus h, then minus x power half squared is going to give us x, this is all over, we have h into, okay, into x plus h power half plus x power half. That's what we have. Okay, so in the numerator, this x is positive and this x is negative, so they will cancel. Then we'll be left with h, and therefore this h will also cancel with this h. Okay, and so what we end up with is equal to, the numerator is now 1 all over, what do we have down here? We have x plus h power half plus x power half. Okay, so for that reason, now we can apply the limit. So we take this back into our limit. So f prime of x is going to be given by limit as h tends to 0 of, so instead of this we will write 1 all over x plus h power half plus x power half. Okay, so that's what we have. So now we can apply the limit. Wherever there is h, we put 0. So this is going to be equal to 1 all over, this is x, so plus 0 power half plus x power half. Okay, so this is going to be given by 1 all over 2x power half, which is the same as 1 all over 2 root x, and that becomes our final answer. So thank you so much, and see you next time.